Hi, welcome to part 4. Almost forgot I was going to show the students that have a newer version of the calculator how you can do it a lot quicker than the way we just did it here. Again, if you don't have a new calculator, you have to go and put the numbers in your list. Again, the observed in list 1, the expected in list 2. Take the observed minus the expected squared, divided by the expected, put that in list number 3, and then find the sum, and then you can find your p-value. Now, those of you that have a newer calculator, stat, test. Now, your calculator will actually have the chi-square goodness of fit. Should be very obvious. There it is. Okay, mine's letter D. Okay, chi-square GOF test. Now, E is, we're not going to use E. I should say letter C is going to be for chapter 4 too. So, pick letter D or whatever yours is. Now, notice how, again, I put the observed in list 1. I put the expected in list 2. I tell it the degrees of freedom, okay, which is not 5. It's 4. Okay, and then calculate. So, boom, it spit it out. That is exactly what we got. If you want to look at the picture, okay, go and pick letter D again. Okay, again, you should always draw the picture. I failed to do that on our first example. Always draw the picture. Okay, draw, and it should hopefully come up. There it goes. And again, these are always going to be skewed to the right. There it is. All right, moving on. Example 2. In this example, lacking a table of random digits, Dan decided to use the last digit in a set of five-place tables of logarithms. Now, no, we're not going to get into logarithms. Okay, this is just the example. The number of times each integer occurred in a sample of size n equals 50, okay, so our sample size is n equals 50, is given below. If the collection of last digits is random, then we would expect each integer to occur on an average or as equally as often. Okay, now before I even look at the table, think about this. Each integer to occur equally often. Okay, there are the digits, okay, looking at the table, we've got the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, the frequency is given below. 0 showed up 8 times, 1 showed up 6 times, 2 showed up 7, 3 showed up 3, 4 showed up 5, 5 showed up 7 times, 6 showed up 1 time, 7 showed up 4 times, 8 showed up 6 times. 9 showed up 3 times. Okay? Now, think about this. There are 10 digits. 10 digits. Each digit, if it's truly random, each digit should occur 10% of the time. Okay, think about it. 10 digits, each number, if it's truly random, should occur 10% of the time. Now, don't get this mixed up. This is frequency. That's how many times the digit showed up. And they took a sample size of 50 digits. Okay, so first of all, our hypothesis. Our hypothesis is going to be that each of the digits are equally likely. Okay, again, equally likely. In this case, each digit should show up %10 of the time. The alternative, each of the digits is not equally likely. Okay? Again, SRS, we must be willing to treat the sample from the logarithm table as a simple random sample. Okay, we're just say that we're willing to treat it as a simple random sample and move on. Do not write proceed with caution. Now, what are the expected counts? Okay, think about this. We have 50 digits. Each digit should show up 10% of the time. That's what we expect. 50 digits, each digit shows up 10% of the time. Well, 0.10 times 50 is 5. Okay? So, our expected counts for 1, for the number 0, we expect it to show up 5 times. The digit 1, we expect it to show up 5 times. The number 2, we expect it to show up 5 times. The number 3, we expect it to show up 5 times. The number 4, 5 times. The number 6, 5 times. The number 7, 5 times. The number 8, 5 times. The number 9, 5 times. Okay, 5, 10, 15, 20, 25, 30, 35, 40, 45. I missed one. 50. Okay. 1, 2, 3, 4. Oh, forgot the 5. 5 to show up 5 times. There we go. All right. Now, 0.10 times the 50 is 5. So that condition is met, remember. All expected counts are 5 for each of the 10 digits, which satisfies the condition for using the chi-square goodness of fit. All right. So now the math. Here we go. So we are going to take the observed minus the expected squared divided by the expected. All right, fill in the numbers. So I'm not going to fill all these in. You can actually abbreviate this. So we're going to start with the number 0. Okay. It showed up the observed values. Again, these are the observed values right here. Those are the observed values. The 0 showed up 8 times. So 8 minus the expected 5 times. So 8 minus 5 squared divided by 5 plus. Okay, now the next one. 1 showed up 6 times. Minus the expected squared divided by the expected. Okay, now I'm not going to write all these down. I'm going to just go plus, dot, 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 plus. Now I'm going to go ahead and do the last ones. Okay, the last two. So the number 8 showed up 6 times. So 6 minus 5 squared divided by 5. Plus, and then the last one, the 9. 9 showed up 3 times. So 3 minus 5 squared divided by 5. Okay, so we can abbreviate. We don't need to write all of that out. Now, let's take our calculator and let's type this in really quick. So again, stat, edit. Okay, in list 1, we're going to put the observed counts. Okay, so we're going to go 8, 6, 7, 3, 5, 7, 1, 4, 6, 3. Okay, and the expected counts, well, that's easy. They're all 5s. 5, 5, 5, and so on. Okay, I don't know what this is doing here. Hold on. Let's see. Okay, now it showed up. All right, so now we're going to go to list 3. Go to the top of list 3. Okay, parentheses. Now the observed are in list 1 minus the expected in list 2 squared divided by the expected. Boom. Okay. I'm going to pause there because I'm running out of time. I'm going to have to do a part 5. So go to part 5 next.